Okay, I got a battery pack of lithium-ion cells. It's from a Lenovo laptop, and this has 4.3 amperes hour, so 5,300 milliamperes hour. And the configuration inside is 3 cells in series, 2 in parallel. So if it's 5.3 amperes hour, it means the cells are, this divided by 2, it's 2,650 milliamperes hour per cell, if I'm not wrong. And then the voltage of the 3 adds up, so it has a nominal voltage of 11.1 volts or a charge voltage of 12.6 volts. So what I will do now is to, first of all, check the voltage of the battery. This voltmeter is not very precise, but it gives me an idea. The battery is quite discharged. The voltage per cell, if we divide this by 3, it's like less than 3.5 volts. So let's say this battery pack is at 20% charge. So I need to charge it 100% and try it again, because like it is now, if I plug these 2 wires to the points where the nickel metal hybrid pack was soldered in the board, it doesn't start the engine when I press the pusher. But if I plug this directly to the terminals of the motor, this works. I will show you. And the voltage here drops like 1 volt, which means like 0.3 volts per cell. So I think it's totally normal, taking into account that we use these very homemade connectors and these very thin wires due to the resistance. So it seems it works, it has enough current, and the capacity is like 4 times the original capacity of the nickel metal hybrid pack. So this should last much longer than the original batteries. If we want to know if the current is demanding, it's tolerated by the battery, we can calculate that with the nickel metal hybrid with 1.3 amperes hour, the vacuum machine had a autonomy of 15 minutes. So it means we need to multiply by 4 the 1.3 amperes hour. It makes like, if I'm not wrong, 5.2 amperes hour. So actually, sorry, 5.2 amperes, not amperes hour. So actually this is 1C for this battery. So 1C, I think it can be handled by any nowadays lithium ions. So I think this will be perfect to make a first trial with this battery project. Okay, see you in the next video.